All right, so today we're going to be looking at something kind of different. We're going to be talking about chicken nuggets.
Chicken nuggets.
Yeah. Chicken nuggets and like some really complex math.
Okay. I'm intrigued.
Yeah, so like imagine you're at like a fast food place, right?
Yeah.
You want some chicken nuggets, but they only come in like boxes of 6 and boxes of 9.
Okay.
Could you order exactly 43 nuggets?
I don't know. That's a good question.
Yeah, and that's like a question that popped up at like the joint mathematics meetings.
Really?
Yeah, and it seems really simple, but it's actually surprisingly tricky.
Yeah, I can see that. So how does something that sounds like a kind of funny food order turn into like serious math?
Well, it's all about the possibilities, right? Like how many ways can you combine those boxes of 6 and 9?
Right. So we're talking about combinatorics, figuring out all the possible combinations to reach a specific number.
Exactly. And it even goes beyond that. Like think about the probability of actually getting that perfect nugget combination. What are the chances?
And you know what's even wilder? This idea actually connects to things like computer-aided design.
Wait, really? Computers use chicken nugget math?
In a way, yeah. When you're designing something complex on a computer like the shape of a car part or a building, you're often working with grids and trying to fit different shapes together efficiently. It's surprisingly similar to our chicken nugget problem, where we're looking for the right combination within a larger set of numbers.
Huh, okay. That's pretty cool. So from chicken nuggets, we're already seeing these connections to some pretty big mathematical ideas.
Absolutely.
Okay, but we also pulled this Mordell conjecture for this deep dive, and I gotta say, it sounds a little intimidating.
It does sound intimidating. It's a really elegant idea, though.
Okay.
So remember, like back in high school algebra, you had those equations like x squared plus y to the fourth equals 4.
Yeah, vaguely. Yeah.
Well, the Mordell conjecture basically deals with those kinds of equations.
Okay.
And it asks, when will these equations have solutions that can be written as simple fractions, like 1/2, 3/4, that sort of thing?
So we're not talking about solutions with like long, messy decimals or anything.
No, just nice, clean fractions. And this is where it gets even more interesting. This conjecture isn't just about equations on a page. We're actually talking about the shapes that these equations make when you graph them.
Okay.
And that's where genus comes in.
Gene. Okay, now you're talking my language. Everyone loves donuts, right? And I know genus has something to do with donuts.
It does. Although in math, genus isn't about how many donuts you can eat. It's about how many holes a shape has, like a donut.
So a donut has one hole, a pretzel has a few more. But how does that relate to, like, equations and their solutions?
Well, the higher the genus of a curve, like the more twists and turns it has, the fewer of those special fraction-only solutions it's going to have.
So more complicated curve, fewer elegant solutions. That's an interesting parallel to our chicken nugget problem, isn't it?
Exactly. It all comes down to constraints and limitations and how those actually can lead to some fascinating discoveries in math, whether we're talking about fast food or complex equations.
So we've got these curves and like all their twists and turns, and it's kind of wild how the more complex they are, the fewer of those like special fraction solutions they have. It's amazing how everything's connected in math, you know? Where do we even go from here?
Well, once Gerd Faltings actually proved the Mordell conjecture, mathematicians are always up for a challenge.
Right. Always got to push those boundaries.
Exactly. So they started to think, what if we took these ideas to a whole new dimension? And I mean that literally.
Okay, now you've got my attention. A sequel, but in higher dimensions.
Exactly. So instead of just curves on a flat surface, we're now talking about surfaces themselves. Spheres, donuts, even those pretzels we were talking about. We're moving beyond those 2D graphs.
Okay, so we're going 3D. But how does the whole solution thing work in that kind of space?
Well, that's where the Uniform Mordell-Lang Conjecture comes in. Barry Mazur came up with it back in '86, and it basically takes Mordell's idea and asks, do those relationships between complexity and solutions, do they still hold true when we're dealing with these higher dimensional shapes?
So are we saying that a really twisty 3D shape would have fewer of those special, fraction solutions than a simpler one, even in like higher dimensions?
You got it. And get this. After years of work, the Uniform Mordell-Lang Conjecture was finally proven in 2021. They found that the maximum number of those special solutions still depends on the genus, even in these more abstract shapes. But here's the thing. These shapes can't just be any random objects floating around. They had to be what we call abelian varieties.
Abelian varieties sounds a bit complicated.
They're a bit tricky to wrap your head around. But imagine like a perfectly symmetrical donut, perfectly balanced, nice hole in the center. It follows specific mathematical rules. That's kind of like an abelian variety that has these special properties that make it, well, kind of like a VIP in the world of mathematics.
Okay, so not just any shape gets to be in the VIP lounge. It's got to be a specific type of shape to have this relationship with the number of solutions. But what does all this even mean? Why should someone who's not a mathematician care about these conjectures and proofs and stuff?
It's a good question. And the amazing thing is, this isn't just some abstract math game. These findings actually impact different areas of math. Like, think about Diophantine problems. Those deal with finding those special fraction-only solutions we've been talking about.
Right.
Knowing the limits of what's possible, thanks to these conjectures, gives us better tools to actually solve those Diophantine problems.
So it's like knowing the boundaries of a maze actually helps you find your way through, even if you don't know the exact path.
Exactly.
Yeah.
But there's a catch. While this conjecture tells us there's a limit to those solutions, it doesn't tell us how to actually find all of them.
Wait, what? We know there's a limit, but we don't know how to find them all. It's like knowing there's treasure out there, but not having a map.
That's a great way to put it. And that leads to something called the Effective Mordell Problem.
Effective Mordell, huh? All right, lay it on me.
So Effective Mordell asks, can we come up with methods to actually find those rational solutions, not just know they exist? Knowing there's a limit is one thing. Pinpointing each solution is a whole other challenge.
So we know the what, but the how is still a mystery.
Pretty much. And it's a tough one. Imagine listing every single combination of chicken nugget boxes to reach a number, not just knowing some combinations work.
Yeah, that sounds really difficult.
Even with powerful computers, this is a huge challenge.
Wow. So we've gone from chicken nuggets to multidimensional shapes to a mathematical treasure hunt without a map.
That's math for you. Every answer just leads to more questions.
It's kind of crazy to think we started with chicken nuggets and we ended up in these crazy mathematical mysteries.
Oh, right.
It just shows how much depth there is to everything, even something as ordinary as a chicken nugget.
Absolutely. It really highlights those unexpected connections you find in math. We've gone from fast food to equations to multidimensional shapes, all in one deep dive. Makes you wonder what other hidden connections are out there.
Right. What if the key to unlocking some huge mathematical mystery is hidden in a bowl of ramen or something?
Exactly. Maybe there's a future Fields Medal winner out there trying to figure out the math behind their, favorite snack food.
That's awesome. Well, this deep dive has definitely given me a whole new appreciation for math. All the elegance, all the complexity. I feel like I've barely scratched the surface.
And that's the best part. There's always more to explore, always more aha moments waiting to be discovered.
So true. So to everyone listening, keep that curiosity alive.
Yeah.
Pay attention to those everyday things and wonder about the mathematical connections they might hold. You never know what you might find. This has been your deep dive into the world of chicken nuggets, conjectures, and mathematical mysteries. We'll catch you next time.